Bismillah ar-Rahman ar-Rahim. Today, inshallah, we will talk about isotopes. We will talk about isotopes. Actually, isotopes is from topic number 3 from IGCSE syllabus. This is a part of topic 3 in IGCSE syllabus. We will discuss together what is the meaning of isotope, how can you detect you have isotope or there is no isotope, and what are uses of isotopes. What are uses of isotopes? First of all, as you see here in the slide, you can see H11, hydrogen 11, and hydrogen 12, and hydrogen 13. Here I have hydrogen, in the middle I have hydrogen, on the right, even here I have hydrogen. What you noticed here, I have three different atoms of hydrogen. Atom of hydrogen here, in the middle atom of hydrogen, on the right atom of hydrogen. What you noticed here? In the first one, you have only one proton. You have only one proton, okay? In the first, in the second, in the third one, I have electron here. In this shell, I have only one electron. Here electron, here electron, here electron. So there is no difference in electrons, no difference in electrons. So focus with me inside nucleus, inside nucleus. Focus with me inside nucleus. Inside nucleus here, the first one, I have proton. I have proton, one proton. And in second one, I have one proton and one neutron. One neutron. P means proton, N means neutron. In the third one, I have one proton and how many neutron? Two neutron, two neutrons. So what you can say I have different atoms, different atoms of the same element, of the same element. What is the element I have here? The element is hydrogen. The element is hydrogen. Atoms of the same element with the same number of proton. Here one proton, here one proton, here one proton. Okay? So with the same number of proton, but different number of neutron, different number of neutron. In the first one, there is no neutron. In the second one, only one neutron, one N. In the third one, two neutron. So you can define isotopes. What you can say? What you can say? Now I will ask some of you about this. Define isotope. Okay. I choose Jasser. What isotopes?
Isotopes are a type of element that have different number of neutrons in the same element. For example, carbon or even hydrogen.
Atoms of the same element. Atoms of the same
element, but have different neutrons.
Have the same number of proton, but different number of neutrons. Yes.
Teacher.
Yes.
What would happen if someone used the hydrogen free and at something like explosive or something?
We will discuss together, Jasir. We will discuss together uses of isotopes. Okay. Now focus in definition of isotopes.
Okay.
Here, definition of isotopes. What is the meaning of isotopes? So I can say isotopes are atoms, different atoms of the same element, have the same number of proton, but different number of neutrons, have the same number of proton, but different number of neutrons. Clear? This is the definition of isotopes. In the first one is hydrogen 1 contain one proton and there is no neutron. It's called protium. Second one proton and one neutron, deuterium. The third is one proton and two neutron is called tritium. Tritium. This is hydrogen 1, this is hydrogen 2, this is hydrogen 3. What is the meaning of hydrogen 1? Contains only one proton inside neutron, inside nucleus. Only one proton. Hydrogen 2, inside nucleus, there are two particles, proton and neutron. Hydrogen 3, there are three particles inside the nucleus, one proton and two neutron. So this is definition of isotopes. Atoms of the same element have the same number of protons, but different number of neutrons. Okay. Atoms of the same element which have the same number of proton, but different number of different neutron number. Even we can say have different nucleon number or different mass number. Nucleon number is the mass number. Nucleon number or mass number is the term refers to total number of proton and neutron. If I ask you here in the first one, in H11, which is called protium, what is the nucleon number? When I ask you about nucleon number, you have to add together number of proton plus number of neutron. Here, there is no neutron, so nucleon number is 1. In deuterium, what is the nucleon number? What is the nucleon number? Nucleon number here is 2. Nucleon number here is 2. In tritium, what is the nucleon number? Nucleon number is 3. So this is the nucleon number. Some isotopes are radioactive. Some isotopes are radioactive, okay? So I have two different kind of isotopes. Two different types of isotopes, radioactive isotopes and non-radioactive isotopes. What is the meaning of radioactive? Who can tell me what is the meaning of radioactive? Just raise your hand. What is the meaning? Who can define? Who can define? Abdullah? Abdullah, can you read?
Mister,
Just read.
I think radioactive is that react quickly or radioactive. That means its nucleus is unstable.
What does it mean unstable?
I know.
Or decay, or giving out radiation. Giving out?
Unstable.
Yes, unstable.
Or decays or giving out radiation.
Yes, or giving out radiation. So again, can you read from the first here?
Radioactive. That means its nucleus is unstable.
Yes, unstable
or
means
decays or giving out radiation.
Example of radioactive is carbon 14.
Carbon
14. Okay, so if you have a sample of carbon 14 will giving out radiation. Okay. Even here, I have isotopes of carbon. I have three different kind of carbon in nature. 3 different kind of carbon in nature. carbon 6 12, 6 13, and carbon 6 14. Carbon 6 12, carbon 6 13, carbon 6 14. You agree with me? 6 is revert to number of proton, so they have the same number of proton, of course, and different number of neutron. Who can tell me how many neutron exist in carbon 6 12? How many neutron exist in carbon 6 12? How many neutron exist in carbon 6 12? You have to subtract. You have to subtract, and you will find number of neutron. Muhammad al-Ashram, how many neutron in carbon?
6.
Yes, exactly. 6. Excellent. So here I have 6 proton and 6 neutron. In carbon 6 13, carbon 6 13. How many neutron? How many neutron exist in carbon 6 13? Just subtract, you will find number of neutron. Who can answer the question? Kareem. Kareem, how many neutron?
5.
How many?
5.
No. You have to subtract to find number of neutron.
Oh.
Subtract, what is the result? Subtract 13 minus 6.
7. 7.
Yes, 7. So Muhammad al-Ashram said what? Muhammad said here, I have 6 proton and 6 neutron. Here, in the second example, Kareem said, I have 6 proton here. And how many neutron, Kareem? 7 neutron. 7 neutron. So what about the third one? How many neutrons here? How many neutrons here? How many neutrons? Abdulaziz?
It's 8.
8. What you did?
I subtract 14 and 6.
Yes, 14 minus 6, so it will be 8. So what does it mean? What does it mean for me? It means the following. In the first one, in the first example here, I have 6 proton and 6 neutron. 6 neutron. Here I have 6 proton also. 6 proton and what? Yes, 13 minus 6, it will be 7 neutron. 7 neutron. In the third one, even here I have 6 proton, and as Abdulaziz said, I have 8 neutron. I have 8 neutron. You can notice here in the first example, I have 6 proton. Second example, 6 proton. The third, 6 proton also. But here I have 6 neutron. Here 7 neutron. Here 8 neutron. So the same number of proton, but different number of neutron. Different number of neutron.
بنقل 1100.
مدير ايش صار؟
في ناس طلعوا ليه عمرو ودول.
تاكد؟
المستر اعطاهم كيك.
لا
عبد الله
يصير.
عبد الله
هلا
يا مستر ما في صوت.
Kareem, read uses of
أيوة.
radiation. Read uses of radiation.
Uses of radiation to check for leaks, to
Yes.
treat cancer, to kill germs and bacteria.
And bacteria. So radiation can be dangerous, and there are some uses of radiation.
Yes.
Uses of radiation, as you said again.
To check for leaks, to treat cancer, to kill germs and bacteria.
Yes. Here the first one. To check for leaks.
مستر ايش الليكس؟
You will see here. Okay. Read. I will discuss with you now. Engineer can
To check for leaks. Engineer can check oil and gas pipes for leak by adding radioisotopes to the oil or gas.
Radioisotopes to the oil or gas. Yes.
To the oil or gas. If the
Geiger counter
detect radiation outside the pipe, it means there is a leak.
Yes.
Radioisotopes used in this way are called tracers.
Tracer. Okay. Here, Kareem, here, if you have a pipe here, oil pipe, okay? Here inside we have oil, and here there is a hole here. How can you detect? By using what? Geiger counter. You can detect by using radiation. Clear?
Yes.
Next one, who can read to treat cancer? To treat cancer. Abdullah, to treat cancer. Second use of
to treat cancer.
Yes.
Cobalt 60 usually used for this because the gamma rays in radiation kills cancer cells.
Yes. Excellent. Here I have gamma rays, and radiation will kill cancer cells. It will not kill normal cell. It will kill cancer cell only. So Abdullah, can I ask you how many uses for radioactive isotopes? What is the first one Kareem said here? Number one, to check.
It's first to check for leaks.
Yes. Second one.
And second to treat cancer.
Yes. The third one, to kill germs,
and bacteria.
So who can participate with me now? Just raise your hand. Who can read? Mahdi?
السلام عليكم.
Walaikum assalam wa rahmatullah. Can you read? To kill germs and bacteria. Uses of isotopes.
To kill germs and bacteria. Cesium 137 used for this gamma rays kill germs and bacteria that cause food to decay.
Yes, so in many countries,
food like vegetables, fruit, and meat are treated with a low dose radiation.
Radiation, okay. Now I will ask a question.
Yes.
Okay. Now I will ask a question. I will write something and I will ask you. Attention with me on the slide. If I have here atom A and atom B and atom C. I have atom A, atom B, and atom C. In atom A, I have 5 proton and 4 neutron. In atom B, I have 4 proton and 5 neutron. In atom C, I have 5 proton and 7 neutron. 5 proton and 7 neutron. which of these atoms are isotopes? Which of these atoms are isotopes? A and B, A and C, B and C. Which one? Which pair are isotopes? Can you detect which atoms are isotopes for each others? So I will choose. Where is his hand? I can see Kareem, Abdullah, Agi. I can see here. Okay. Ali, which pair are isotopes?
السلام عليكم يا مستر.
وعليكم السلام.
الايستوبس هو A و C يا مستر.
A and C. Why? Can you tell me why? A and C. Why?
Because number of proton are same thing and number of neutron are different.
Yes. What is the total now? What is the number of proton and neutron in A?
A 5 proton and 4 neutron.
Yes.
And C 5 proton because it's same and 7 neutron.
Yes. Thank you. Thank you, Ali. Yes, you are correct. Good job. So Ali said A and C are isotopes for each other. Why? Because they have the same number of proton but different number of neutron. What I need to say? I need to say isotopes have the same chemical properties. Have the same chemical properties. If I'm talking about chemical properties of carbon 612, the same chemical properties of carbon 613, the same chemical properties of carbon 614. Why? Because all isotopes have the same number of electrons. Have the same number of electrons. Okay. As you know here, carbon 612 is the number, 6 is the number of proton, even it's the number of electron. Here in carbon 613, number of proton 6, number of electron 6 also as well. In carbon 614, number of proton is 6 and number of electron is 6 as well. Okay, so isotopes have the same chemical properties because isotopes have the same number of electrons, have the same number of electrons. Just to check here another slide. Okay, I need to talk about this. So here, as you see here, carbon 612, carbon 613, and carbon 614. Here in number 3. Here, yes. Here we have example of isotopes, hydrogen on one proton only. In the first one, in hydrogen on 1, I have 1 proton. In deuterium, I have 1 proton and 1 neutron. In tritium, I have 1 proton and 2 neutron. Okay. Okay, boys. So let's go to back here. Can you hear me? I think there is a proper internet connection. Jasser, can you define isotope? Jasser, can you define isotope?
Isotope is an element, is type of elements that have same number of proton but different neutron number.
Yes, same number of proton but different neutron number. My question.
The same elements.
Yeah, must be the same element. Must be the same element. Okay. Clear? Must be
Yes.
the same element. The same element. Abdullah, can you tell me why isotopes have the same chemical properties? In general, when there is a question about chemical properties, I'm referred to Number of electrons. Number of electrons. Chemical properties means electrons. Abdullah, can you tell me why isotopes have the same chemical properties?
Because number of protons and electrons are always the same.
You have to refer to electrons only. When I'm talking about
And it's
chemical properties, refer to electrons,
yeah,
not to
yeah,
protons.
and all number of electrons are the same. All are
Yes,
six.
yes, exactly. Because they have the same number of electrons, because they have the same number of electrons. Okay. Who can tell me uses of isotopes? Is there any importance for isotopes in our life? Who can tell me the uses of isotopes? We talked about it here, as you see on the slide, uses of radiation of isotopes here. This is the third one. Who can tell me one by one? Uses of isotopes. Uses of isotopes. No, I need another one. Muhammad Ashram, can you tell me uses of isotopes?
ايش؟
Uses of isotopes. Here, the first one. Here, what you can see. To check for, Karim said it before. To check for. To check for.
check oil and gas pipe.
Yes.
What?
Second one. To treat.
To treat cancer.
The third one.
To kill germs and bacteria.
To kill germs and bacteria. Okay. Okay, Abdulaziz, go. No problem, go. No problem. So who can define isotopes? Ali Yami? Ali, can you define isotope? Define isotope. Define isotope.
Isotopes is two elements that have same number of proton and different number of electrons.
You are very good, but you have to say atoms of the same element, not two element. I'm not talking about element. I'm talking about atoms of the same.
Atom.
Yes, atoms of the same element. Yeah. Can you say it again?
Atom of the same element that have the same number of proton and different number of
neutron. Different number of neutrons. Yes. Thank you, Ali. Okay. Now I need to draw something here. Okay. If I have here nucleus and here nucleus and here another nucleus. Okay. In the first one, I have like that. Okay. And I will say, what is this? This is A. This is B. Attention with me, please. Attention with me. In B, I have like that. The third one I have like that. Okay, where X refer to electron, X electron, and the circle is neutron. X is electron and the circle is neutron. Which pair are isotopes for each other? Which pair are isotopes for each other and why? So you have to focus inside the atom here. Which pair are isotopes and why? Karim, which pair are isotopes?
A and B, because they have the same
same number of
and different
have the same number of
electron.
what?
of electron and different of
sorry,
neutron.
sorry, boys. Here, X is proton. Sorry. Because inside nucleus, there is no electron inside nucleus. X is proton.
Okay, because they have the same number of proton and different number of neutron.
Yes, exactly, Karim. Because they have the same number of proton, so X is proton, not electron. Okay, again, Karim, tell me your answer.
A and B because they have the same number of proton and different number of neutron.
Yes. What are numbers of protons?
X.
What are number of protons? How many protons? 4 in each one. Yes.
4.
Yes. And how many neutron?
Yes.
In A? How many neutron in A?
2 and B 3. They are different.
Yes. So the same number of protons, but different number of neutrons. So isotopes are what and what?
Different number of proton and
no, the same number of
no,
protons.
same number of proton and different number of neutron.
So which nucleus here are isotopes for each other? Which atoms? A and
B.
A and B. Yes, exactly. Thank you, Karim.
You're welcome.
So, boys, as we said, isotopes are different atoms of the same element, have the same number of protons, but different number of neutrons. Why isotopes have the same chemical properties? Because they have the same number of electrons. Okay, clear? And we talked about uses of isotopes. As you see here, uses of isotopes is very, very important. So you have to be aware about uses of isotopes here to kill germs and bacteria, to treat cancer, to check for leaks. Thank you for listening. Now I'm ready to receive any question from anyone.